We now introduce program graphs, a special kind of directed graph that describes the control structure of programs. Here we have an example of a program graph. There are 5 nodes. The one at the top is labeled Q open triangle and is called the initial node. The one down on the right labeled Q closed triangle is called the final node. The remaining nodes are called Q1, Q2, and Q3. There are 5 directed edges. The one from the initial node to Q1 is labeled Y becomes 1. The one from Q1 to Q2 is labeled pass if x is greater than 0. The one from Q2 to Q3 is labeled y becomes x times y. The one from Q3 to Q1 is labeled subtract 1 from x. And finally, the edge from Q1 to the final node is labeled pass if x is less than or equal to 0. This program is intended to compute the factorial of the initial value of x and leave the result in the variable y. In general, a program graph consists of the following components: a finite set of nodes called Q. In the example on the left, there were 5. And the 2 special nodes, the initial node and the final node. We shall require that there is never an edge leaving the final node. A set of actions. In the example on the left, they were y becomes 1, pass if x is greater than 0, and so on. And finally, a set E of direct edges labeled with actions. The one from Q1 to Q2 saying pass if x is greater than 0 is represented by the second triple Q1, x greater than 0, Q2. Now is the time for you to try and construct a program graph for a program of interest. The program we have in mind computes a power function. So the final value of y should be 2 to the power of the initial value of x. Draw a program graph for this program and invent any new actions that you might need. Once you've done that, you should read the section in the book doing the try-it outs on the way.